Hello everyone, John NFA here. And before we start the video, I'd like to give a quick disclaimer. Despite my YouTube username being John Teacher, I'm not a real teacher. I'm rather a student of computer science who's willing to work through some problems. And today we're working with NFAs, or in other words, non-deterministic finite state automata. So before we start, I'd like to describe the alphabet that we're working with for all the problems today, which is binary strings. All right. Oh, it's cutting off a little here. Sorry about that. All right. So today, the first language, X is going to be an element of our language such that X contains the substring. Oh, looks like an A. Apologies. Substring 010. All right. So, as always, a key reminder is that if you can't think of an NFA to do something and you've been working with a lot of DFAs, you can simply write it out in a DFA. So, to start, I'll be writing the first problem out in a DFA. For the rest of them, though, I'll stick primarily to the NFAs. So, let's think about how we could do this as a DFA because, you know, any NFA or any DFA is an NFA. So, let's think about it in terms of DFAs. It contains the substring 010. So, as always, if we contain a bunch of ones, or write it like this, 1, 0, 0. And if you haven't seen the DFA video series, I strongly recommend doing so as they really help the thought process behind this right here. This is our accept state. So, as a friendly reminder, contains the substring 010, 0, 1, 0. Okay. And we basically put a self loop at the end because we want to contain anything afterwards, right? Let's work through a quick example. Say we have a bunch of ones. Oop, getting a little messy here. Bunch of ones, 0, 1, 0. And then we have, I don't know, a bunch of zeros. Well, we can still contain the substring. So we loop through a bunch of ones, and then we have a bunch of zeros, or maybe even ones at the end. You never know. But either way, we capture both cases there. And primarily in a DFA, we want to transition for everything to be accounted for. So let's work through that. Oh, not sure what's going on there. Sorry about that. All right. So, and I forgot to label my states. I can't believe this. You should always label your states, by the way. Strongly recommended on exams. But yeah, Q0, Q1, Q2, Q3. All right. So for Q0, we have 1, we have 0. So Q0 is complete. All right. Q1, we need to define what we would do on a 0 case. Well, let's think about it. See a bunch of zeros, or not see a bunch of zeros, sorry. We see a couple ones, we see a 0, we see a 0, and then we see a 1, 0, and then 1, 1, 1, 1, 1. This is the substring we want. But look, we repeat this 0. Do we go back to the start? No, not quite, because we still see a 0. So we want to stay in Q1 when we see a 0. So we self loop on 0. Okay. That's Q1 accounted for. 1, 0. Just like that. Q1. Next we got Q2. Q2 is defined for 0 right here. So we need to define what would happen on a 1. Sorry about that. Dropped something on my iPad. We need to define what we would do on a 1 for Q2. So let's think about this. We're tracing through. We see a 0, we see a 1, and then we see another 1. Well, if we see a 0 and then a 1, 1, there's no real substring we could work with. So the best we can do is go back to the start. Take it home. All right. So for Q2, we have a 0, we have a 1. Q2 is accounted for. And Q3, we have a self loop right here. So Q3 is accounted for. Sorry I went through that a little bit quickly, but we all know, or hopefully by now you know, if you haven't, I strongly encourage you to look at DFAs as they help the thought process of NFAs. But yeah, hopefully by now you understand the DFA portion, but let's break it down and think about what we can do with an NFA, right? So I'm going to start with the same states actually. Q1, Q2, and then Q3. This is still problem one. I want to highlight this. Still problem one. But we're going to write it more in terms of an NFA sense. Though it's not really a thing. It's just we could minimize it, or we can minimize it here. Okay? Like, see this one transition, this zero transition? We could get rid of stuff like that. So, as always, we're going to need the substring right here, right? Say we got an example 0, 1, 0, and we got dot, 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 dot. The dot, dot, dot's being representative of the rest of the binary string. Still want our self loop at the end. That's not really going to go away. But what makes this really more non-deterministic in a sense is that we don't have to define, say, a one transition that takes it home right here, correct? Or, not a one transition, a zero transition that puts on a self loop. Because we don't have to be exact in how we take our path to things, if that makes sense. So let's say a better way to describe NFAs, let's say you're maybe less NFAs. Let's say you're on a path, right? You're on a path. And you see a little sign, like a crossroad, okay? And it leads you two ways. And you can decide. Now, I don't know. Let's say for one random reason, this way's dangerous, okay? It's bad. But we don't know that it's bad because, I don't know, maybe it's a bad sign or something. Let's go with that. Terrible sign. So, what if in a way, which this is you, we could duplicate yourself. You could duplicate yourself. So you have one version of you going down this path, one version of you going down this path, and this little guy right here can basically just see which one of your clones is still alive at the end. Maybe you could feel it or something. So let's say this clone, I don't know, something happens to him, but this clone survives. Well, now you know that this is the correct path. So you go here. Bit of a interesting demonstration that I just made up on the spot. But let's start thinking about it with NFAs. So back to here, what I'm going to try is I'm going to put a self loop of 0, 1. And you're going to see why. So notice how I want this substring, right? And the cool part about an NFAs is that I don't really care about what's here or what's here. So what I could simply do is 0, 1, 1, 1, 0, 0, 1, 0, and then 0, 1, 0, and then we accept once after we go through maybe a couple self loops. Okay, that's that non-determinism, but that was the perfect path. Even though we have the right substring right here, we might not take the perfect path. A good example of this might be, what's a good example? Maybe let's go 1, 0, 1, 0. And we have one of our duplicates, like I said, and he's going down the bad path. It's kind of unfortunate, but it could happen. So he takes it 1, 0, 1, 0. Well, that's not an accept state, but we have the substring. But that's the whole point, the whole entire aspect of non-determinism. And you'll see maybe in a future video that I might make later, you might question, well, how is this good that we could have non-determinism? Like, isn't the runtime complexity insane? We'll see later that we can convert any NFA to a DFA, but that's a later video, of course. But I just wanted to highlight that if you are having that concern, it's okay. There's a way we can solve this. But for now, we're just going to work with what we have. And yeah, so believe it or not, this is actually the complete NFA. I'll box it for clarity. For the language of strings that contain the substring 0, 1, 0. But yeah, spent a little bit moving on. Tried to intro the subject, so that's why. But we'll start working through them a little quicker. So next, we're going to look at the language. Going to look at the language where x is an element of 0, 1 star, length language of binary strings, such that x starts with, oh god, handwriting, starts with 0, 1, 1. Okay. So we're thinking about the language where x starts with 0, 1, 1. Reminder, this is an NFA, so let's think through it. I'll start drawing out the states. If you haven't seen the DFA video, a strong recommendation that I always have is to make as many states for the length of the string when it comes to substrings, or plus the start state, of course. But to highlight what I mean here, if we have 3 numbers that we have to work through, then I want the start state plus 3 states. Okay, just to highlight that there. But yeah, okay, so we want a string that starts with 0, 1, 1. I don't know. And sorry, Q3 is the accept state. Didn't highlight that before. Starts with 0, 1, 1. Okay, we could do the self loop that we did before in the previous problem, except it starts with 0, 1, 1. So if we had the start state right here, and it was looping through a bunch of 0, 1, 1s, and then, like, let's say 1, 1, 0, 1, 1, and this is our substring. Well, non-determinism just tries to find a correct path, no matter how many attempts it has. So 1, 1, 0, 1, 1. So that's not going to work. Gonna have to get rid of that. But we could still leave the self loop at the end, right? Well, I mean, yeah, as long as it starts with 0, 1, 1, and it has whatever it wants, then it should work. So yeah, this is a complete NFA for the language of X that starts with 0, 1, 1. And I don't know, maybe it's a personal thing, but I used to watch a lot of YouTube videos when I was in theory of computation. But I always felt kind of ashamed that when they give me a new problem like starts with or something, that I had no idea like to think of it that way. So I want you to think of a language where X is an element of any binary strings such that X ends with 0, 1, 1. And if I forgot to mention it at the start of the video, I always encourage you when I write down the language of a problem, I'm going to work through it immediately, but take time, think through it, because end of the day, the answer is always going to be out there. But what matters is that you understand, like when you see the problem being written by you and you find that mistake, that's where the real learning occurs. Because you might think in your head, you're looking at a problem. It might make sense, but when you were writing it down in the given moment, that's where you really understand flaws that, how, oh God, losing train of thought. That's where you really understand the flaws that you could never truly see by just watching somebody do it. But yeah, well, I hope that was enough of an excuse for you to write it down. But without further ado, let's draw all our states. I won't spend too long on this one because the video is already getting pretty long. But yeah, 0, 1, 1. We want it to end with 0, 1, 1. So do we put the self loop here? No. I want it to end with that. So we put it there. And yeah, that's a successful language of the NFA where X ends with 0, 1, 1. Just to highlight this, it'll try any combination. It'll keep going, keep guessing. Maybe that fails. So it goes back. Oh God. Sorry about that. So it goes back, doot, and it tries a different strategy. Maybe it goes doot. It makes it, but let's say it has an extra character and then it falls off. That's very possible. I guess I should highlight that actually. Let's take a moment. Let's say we have 0, 1, 1, 1. The NFA does cover that case because if it goes 0, 1, 1 and it ends in this state, but it has an extra character and it doesn't know where to go, then that will terminate and it will not accept. So just to highlight that, clarify any concerns that you might have. But yeah, let's move on to the next problem. Start moving through a little quicker here. Number 4, the language of X is an element such that the third X's third to last character is a 1. Okay, so we want an NFA third to last character is a 1. Oh god, handwriting. Ignore that, ignore the crime scene. But yeah, let's think about this. So third to last characters. So, what's that going to mean? It's going to mean we're going to have something here. Oop, it's a little small. Third to last character, something here. And one more character. Q3. And something here. Okay, we don't want a self loop at the end because it's the third to last. We've seen that from the last problem. And we know that we want the third to last to be a 1. Okay. And the other two characters, the second to last and the last character, well, frankly, they could be anything, right? And Q3 is the accept state. Almost forgot. Yeah. Correct me if I'm wrong in the comments if I ever forget an accept state. I do deeply apologize for that. But yes, so third to last character is a 1. So that covers the case of a character, like 0 or 1, or, oh, come on, 1 or 0, 1, 1, 0, 0. Covers all those cases. But it's third to last, so that means it could start with anything. And yeah, not going to work through examples, starting to move a little quicker. That is the language for the DFA, where X's third to last character is a 1. Let's move on to problem 5. All right. The language of X, ln of 0, 1 star, such that X contains at least 1, 1. X contains at least 1, 1. And I wrote out the word here because I don't want to obviously write 1, 1. That might confuse people, but at least 1, 1. So what do I mean by that? If you're familiar with regexes, this is what I mean. If you're not familiar with that, I'll make a video later. It's describing what I mean by there, but basically it means 1, anything, just as long as we have this guy right here. All right. So you need to think about this. Well, we have a start state Q0. We need at least 1, 1, Q1, accept state. All right, let's think about NFAs. Well, it could have anything after the 1. Could have anything before the 1, even including a 1. Does that solve it? I think so. Might be simpler than we think, because non-determinism always ensures that we have, if there's a path that's correct, then the string will be accepted. So we could take zeros and ones. Maybe we didn't take the 1 and we end up in Q0. Well, it's okay that path didn't fail. It's like I said, try to scroll up there. It's like I said earlier. We could take the bad path, but, it's going to keep trying until maybe, hopefully, it finds a good path, unless there are no good paths, and it'll be rejected. But yeah, basically, through this anything, just loops around here, finds the 1, and then through the rest of it, loops around here and accepts. So yeah, that is the language of an NFA that contains at least 1, 1. All right, so for our last problem, we're going to look at the language of X, so elements of 0, 1 star, such that X contains 1, 1, 0, 1, and 0, 1, 1. Did I write it down right? I think I did. Okay, so we're going to show this 2 ways. One way is just the brute force way. Well, let's think about it how we've always been doing it, just with a little twist. All right, let's draw Q0. Let's go 1, Q1, 1, Q2, except, well, that covers the 1, 1 case. Almost. Sorry, I apologize. Got to draw our self loops. So yeah, that covers the 1, 1 case. So now let's think about 0, 1. Okay. 0, Q3, 1. That covers that case. All right. 0, Q4, Q5, 1, 1. And yeah, it pretty much, think about the non-determinism way. If it contains a 0, 1, it'll try these other paths, but eventually it'll try the path that accepts. But yeah, we could walk through some examples on your own. This video is already getting quite long, but that is the brute force way of accomplishing it. And I even recommend it if your exam doesn't specify a maximum number of states to use. I'd highly recommend just drawing it out a brute force if it's not too lengthy, because you could always verify. Maybe it's easier for you to verify that it's right because this isn't wrong. This isn't a completely acceptable NFA. But let's just take a moment to think about how could we minimize this? How could we use less states? All right. Let's start by writing 3 states. Q1. Let's take our longest substring to work with. Q3. And that would be 0, 1, 1. Except state can have anything after and anything before because it is a substring. All right. What were those other strings? The goal. 1, 1, and 0, 1. Just scooching it down a little bit. But the goal is to have 1, 1 and 0, 1 without containing any extra states. All right, let's think about this. Let's start with 1, 1. Well, we could make a state, right? Don't want to do that. Do you see another way where we could already use what we have to get 1, 1 to be accepted? I think I do. Let's try this. 1, 1. Let's think about it for a second. 1, 1. Anything before, anything after. Looks good to me. All right. Let's start thinking about 0, 1. Same thing as before. 0, 1. And look at that. I mean, there might even be a better way to do it. Think to yourselves, maybe you could show me in the comments a better idea. But look it, we had 1, 2, 3, 4, 5, 6 states, and we reduced it to 4. It's a lot simpler in my opinion. A lot nicer to look at too, depending on the circumstance. But yeah, this has been some NFA practice with John NFA. Thank you for listening.